All right.
There it is.
All good?
Okay, this gets both the video and the audio?
Yes.
Okay, cool. So the purpose of the training is to go over our managed firewall, on a more technical level. Some of you have had some brief experience with it. Does everyone understand everyone understand the basics of how the firewall operates?
Yeah.
Yeah. Just want to make sure we get that out of the way. It's basically a barrier between a customer's private network and the external network, the internet. So there's several firewalls in our network. Cloud-based firewall. We don't provide on-site firewall, on-premise firewall. That is, it's all in the cloud. We don't do really any NAT on the Cisco's. That can be a temporary thing if need be, but it's not a long-term thing. If a customer wants managed firewall from Fusion, they have to purchase the managed firewall product. Can everyone see my screen?
Yes.
Okay. So on the router level, you have a customer's VRF, and then you have the firewall, and then you have the default VRF or the public internet facing site. So I'm in the Newark router, and let's look at the 500A firewall cluster. Now, there's going to be some physical topology changes to these firewalls. Right now, they're plugged directly into the Burr router in Miami and in Newark. But down the road, hopefully next week or two, once we get the 3750 switches, they'll be plugged in behind that, and then the 3750 switches will be plugged into a lag port facing the Burr router. So there's true redundancy to the customers, with the HA. But for now, they're plugged into the Burr router directly. So let's look at the actual internal and external interfaces. So it's, you have, on a FortiGate, you have a limitation of 10 VDOMs, including the root. If you have the lower end devices, I think you can get at least 1000D to be able to get a unit that you can license out VDOMs. Virtual domains, meaning like it's the equivalent of a VRF on a Cisco router, or context on a Smart Edge. So scroll down. Let's get one of them here. So if we look for, here's 100D, but here is okay. So here is the customers on the 500A firewall. As you can see, it's labeled. The base port is labeled, the A firewall. You can see all the external facing interfaces. They're on sub interfaces facing the firewall. So each VDOM gets a sub interface, and then you append it with a VLAN. It looks as such. It looks exactly like that. Now you have the inside interface. Van Dyke. So here we go. This is the internal facing interface that resides in the customer's VRF. It's like on site is if customer had an on-premise based firewall, their LAN would connect into the inside of the firewall. This is the same thing. The internal side in the customer's VRF is like the inside of their network. So traffic passes through the firewall on the inside, goes, gets natted out the firewall, or if there's any IPsec tunnels, gets encrypted over the tunnels, and then it traverses the external side. Now, as you can see, with the inside and outside on the 500A FortiGate, you'll see that the internal and the external side are the same VLAN. That is because they're on different ports. When this is moved to the actual aggregation, the true switches that are going to connect to all the firewalls, it's going to have to be a little a configuration change, because you can't have the same VLAN for two different interfaces. So we'll probably have to do a Q and Q that separate the internal and the external side of this FortiGate. This is over here. This is another firewall. This is 100D. There's only a single 100D in Newark right now. And here's the external side, and then there's a corresponding internal side. I don't remember where that is right now, but if you look at my carrier hub sheet, you'll find out where that internal side resides. This 100D is going to get migrated to a pair of 200Ds once we get the switches and everything. The 500A firewall is going to stay. It's just going to be physically moved to the switches. So just Does anyone have any questions on how this actually works, as far as, connecting to the actual network?
The connection, no. In terms of how do we decipher between the 500A and the 100D? I mean, what decides what goes on what?
Okay, so that's a good question. So right now, I believe the VDOMs are all in use on the 500A. Once we can get in there and count. But if there's 10 VDOMs in use, then you can't use that firewall anymore. Then you have to use the 100D, pretty much. And what's going to happen down the road is we're going to stack these firewalls. There's going to be a stack of 200Ds, and once all those VDOMs get used, then we'll put another stack of 200Ds, and then you just keep using. It doesn't matter which one you put them on. To be honest with you, you just keep putting them on a firewall, and then once all those VDOMs are used, then then we'll put another one, and you can put them on that one.
Right. So for our side, all we care about is what the internal and external interfaces on the firewall we choose.
Right, and if you look at the Burr router, and if you look on my carrier hub sheet, you'll see which side the physical port on the firewall connects to. So that'll dictate which one you put your sub interface on. And again, in the next week or two, hopefully, when we get those stacked switches, it'll come back to a lag 20 gig port on the Burr router. So instead of physical interfaces like this here, it'll connect to one bundle Ethernet to the switch, and then there'll be to the Burr router between that and the switch, and then you'll have like all your sub interfaces off of that bundle Ethernet. So it'll be a lot more simpler. And then it's going to be 240 port switches, and we're going to stack a bunch of as we go, we're going to stack firewalls on those switches until we get to a point where we can put a larger firewall there that can license out VDOMs, or we get a virtual appliance.
So now the answer is for that is pretty much it's either one, whatever's available, correct?
Exactly. Yes. Exactly.
All right.
So let me get into Miami, so I can show you Miami quickly. So Miami is the only other facility that we have customer managed firewall. And as the requirements come, like customers come that need, say, if we get a customer out west, that needs managed firewall, then we'll get a stack of firewalls out there with some switches. But right now there is not currently a stack of firewalls out in LA or out west. So if you look at the Miami Burr router, in Miami there's there's a 400A firewall and there's a 200A firewall, and the corresponding sub interfaces. For now, and you want to write this down. The 200A firewall is only 10/100 WAN ports. So if you have like a bunch of T1 customers that are coming back to Miami, low bandwidth customers, you can put them on the 200A. This is the only exception. And then any other high capacity circuits, 10, above 100 meg, you can put them on the 400A because that actually has gig ports. And the plan is, just like we're doing with Newark, we'll get a stack of switches with a stack of 200D firewalls. We'll put them in Miami, and then the 200A and the 400A will both be condensed down to the 200D. And then at that point, it doesn't matter who you put on that until you run out of virtual domains. And the standard going forward for the stack of 200Ds will be a 2 gig lag internal and a 2 gig lag external port to the switch. So you will have 2 gig external available, 2 gig external available, and then you have the 20 gig lag up to the Burr router. So you should really have no contention issues at that point. Unless you get a customer who says, I need a gig of bandwidth, for a bunch of sites going through a managed firewall. But, we don't have that requirement yet.
Sure. And in terms of the VDOM itself, I mean, if it's full, it'll just give you an error, or are you going to show us how to check?
Yeah.
What's what?
So everybody understands, how it connects to right now, currently how it connects to the actual Burr routers. Do you have any questions on that? Are we good?
I understand.
We're good. Yeah, I understand. Okay. Inside, outside, on 2 separate interfaces.
Right. And, I'll send an email out when that migration takes place to move to the stacked 200Ds and behind the switches with the bundle Ethernet. But for now, this is how it's configured.
When you move the switch interfaces or anything, is that going to affect our configs, or are we going to have to go back in and change everything, or are you going to handle the migration on the...
So what'll happen is, the NOC will probably do the migration. I can get to this firewall without getting locked out. And I just locked myself out. So quick note, if you fail a FortiGate login 3 times, it locks your IP out for like a couple minutes, as you can see there. Down the road, all the customer FortiGates will be TACAX enabled. As right now, only the 100D in New York is. I'm sorry, George. What was our question again?
I was just asking questions about the migration. Once we do the migration, will we have to change? Will we be helping with that, or is there going to be any changes that we need to do on the actual firewalls themselves, or are you like setting for stuff, or?
So what'll happen is the existing configs on the firewalls right now will be replicated to the new firewalls that are deployed, and then one night there'll be a migration. The NOC will do they'll remove the interface off of the old firewall, the sub interface, and then they'll rebind it, or apply the IP address to the new lag port sub interface. So from your guys' perspective, just keep doing what you're doing, and then once the migration actually happens, once I have the 200D firewalls, what'll happen is transparently we'll move the policies over, we'll duplicate the policies on the new firewall, and then one night when we're ready to cut over, I'll allow the VLANs on the trunk port. But up until the migration, I'll restrict the VLANs on the trunk port, so so there's no service disruption.
Okay.
On the new one. There we go. So this is a 500A. So just a note, if you look here on the main page, you see that there's a master and a slave. So this entails that this is an HA cluster. It tells you what's actually active. And someone joined the call?
Yes, Donnie.
Okay, hey, Donnie. So if you go down here, so this is an older firewall, 500A, so the GUI may look a little bit different than a newer firmware, or like say a 200D or a 100D or a 40C that has an upgraded firmware. So on the bottom, you see you have the list of the virtual domains, and you see all those that are available. The root does count, so we have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have one more customer that we can put on this firewall. Each customer gets their own virtual domain. Way in the beginning, we put customers who didn't need their own VDOM into a shared one, but we no longer do that. So if you actually look at the interface, you can see which customers traverse this virtual domain. Once you hit the VDOM limit of 10, what will happen is if you go to try to create another VDOM, it'll say reach the maximum amount of allowed VDOM, and you can see right here how many are allowed. FortiGate construct is pretty simple. You can go to the VDOM section. You have all the list of VDOMs and what interfaces belong to that VDOM. You can go to the interface section and see what's available. And you click on one, you can see its its configuration parameters. This is a VLAN ID that interacts with the actual sub interface on the Burr router. I can't figure anything here. So this is the HA section. You guys don't really need to be concerned with, but this is where you see like this is the primary, secondary, SNMP stuff, and some other admin stuff. So this is where I'm right now. This is considered the global VDOM or global section. This actually does not have a customer configs pertaining to customers. If you want to look at a VDOM that has customer configs, you would select one. So let's look at Bottle King. So if you look at Bottle King, you can see the interfaces that only pertain to that virtual domain. So here's the inside, and here's the outside. This faces the customer's VRF, and this faces the external VRF. So now if you go to router, this is your static routing section, like on a Cisco router. Basically, any managed firewall product we provide a customer, you're always going to point a default route out to the, the Burr router facing the outside interface. Everything's going to that interface, that outside interface. And then anything to do with their LAN subnets have to be pointed inward. So when the traffic gets natted, unnatted from coming back to the internet, the firewall needs to know how to route that traffic, back to the site. So how you do that is you point a route for their LAN subnet back to the inside of their VRF or the BR router. Does everyone understand that concept?
Yes.
Yes.
Okay. There should really be no need for any dynamic routing. We have done dynamic routing BGP, and there's a customer in Miami that does OSPF, but that's on an ICB basis. 95% of the time, it's always going to be static routing, static default route out to the, to the external VRF, the default VRF, and then their specific LAN subnet back to the inside of their VRF. So the firewall knows how to get back to those LAN subnets when it unnats the traffic. You can do some policy routing. Don't really have a need for it on a customer basis since we're not really going between VDOMs. Some settings here you can do some load balancing really is not needed. And then here's your dynamic routing section if you would need it. And here's your routing monitor. A thing to note about FortiGates is sometimes if you put a static route in, it's not, and you notice that you're not getting traffic for some reason, go to your routing monitor. If you do not see the route that you just inserted in the routing monitor, it is not active in the firewall. I would suggest taking out the route a few times and putting it back in. If at that point it does not become active in the routing table, in the routing monitor, then you would engage me or network engineering to investigate. Because I have seen instances, very rare cases before where the routing doesn't become active in the routing monitor, and it requires a reboot of the firewall. So that's your static routing section. So this is like your equivalent of doing on a Cisco router, like your IP route statement. This is basically what this section is your IP route statement. This is dictating where it sends the traffic. Okay? But because this is a firewall, it's more than just a router. It can encrypt traffic. It can do a bunch more. So into your policy section is where what you actually do with that traffic. So if you look here, this is a general in-to-out NAT statement. Anything coming from the inside of the VRF to the outside interface, you're basically going to NAT it and use the destination interface. So this is the external interface for the NAT. And then you can log it if you want to. So, and then just like any other firewall or access list, there's an implicit deny at the bottom. Even if it's not stated, it's always there. And then you can go to your policy monitor and see all the different types of traffic that may be traversing it. So under your firewall objects here is where you define, let me use a different example. Hey George, did you define the policies here or the objects and stuff or not yet?
No, I haven't decided. You're talking about the NAT, the individual NAT objects where people want to be able to get to like the security cameras. No, I have not done that yet. No.
Okay. So I'm going to use another example that does have one defined. So I'm going to, is this a good one? Let's see. Let's not use that one. I'm going to use a different firewall that has a better example. At one point, we did use three other.
Just another note, all the various firewalls seem to have different, I'll say iOSs. So the options are sometimes in different places. Just wanted to tell people that.
Yeah.
But they're all
when we do use it. Yeah. The 200Ds going forward will be the same firmware as a 100D that I'm about to go into. So it'll be kind of standard going forward. When Fortinet upgrades the iOS on this stuff, get the right IP address. When they go between major releases, they change the GUI and whatnot. It's a pain in the ass sometimes because you got to find where they may have moved an option. This 100D is actually TACAX enabled. So if you notice, this little GUI is a little bit different than the 500i that I was in. Everything's still available. It's just an upgraded firmware. The virtual domain is on the bottom. And instead of having a list, you have a list on the side here. So you see everything here. So let me go to X1. This is the one that I did. So again, everything's there. The static routing section, there's a little bit more. So if you see here, there's a default pointing out the external side, and then here's all the customer's LAN stuff, and that's pointing to the inside. Now, for SIP traffic, the only SIP traffic that should traverse the firewall wall, the only traffic concerning SIP that traverses the firewall should be DNS resolution if the phones or PBX needs to do that. Because, we can't, the issue becomes is we don't want to have to interview throughout the private IPs to and from the DNS servers, because we could technically hijack the customer's DNS resolution for their internal subnet, their data, so that could be bad. So any SIP traffic gets into a VRF routed directly out of the VRF, to the register IPs. Any DNS traffic can come through the firewall for DNS resolution. For like phones or, for SIP, PBX that needs to do DNS resolution to our for name resolution. And, again, you just point a route for that traffic back to the inside of the VRF, the VIR router. Now this has some stuff defined. So this actually has a dialog VPN too. So here's another thing we can go over. So if you look here, you have an internal to external policy. So here's your global NAT rule. Basically, anything from the inside going to the outside, you're going to NAT it and use the outside interface. Now, here is an IPsec rule. What this basically says is anything coming from the inside of the VRF, coming from a source address of X1. Now, this is an address group, which I'll go over, to the outside to an address group of X1 Europe. You're going to encrypt it, and it's going to be sent over the Germany VPN that I have created. It's a site-to-site VPN to Germany. We do not control the Germany firewall, so this was done, as a call, a turn-up call, because they have a watch guard that we had to interop with. So if we go back to the policy section, now that covers the internal to external. For the external to internal, these are basically port forwards. The way I do port forward on a FortiGate is I do it via virtual IPs. So if you go, let me go to the object section first. So this is where you define all your objects, that you can reference in the policy. So, so you have North Huntington data, you have and so on, you have Las Vegas data, and here's your address groups. Address groups is basically just creating a name and then putting a bunch of individual addresses in that group. So in the policy, instead of having 5 different addresses, you can, use a group instead. It makes it look cleaner. Under the virtual IP section is pretty much where I'm doing the port forwarding. So if you look at one of these examples, you see I am doing the name, and then the external IP, the internal IP that it's mapped to, and then I have port forwarding enabled. Port 80 is what is being forwarded from the to the inside. You'll notice in the recent version of the FortiGate, you don't have a let me show you as an example. So let's go to Bottle King as an example on that a little bit to show you. God, it's killing me. I think the firewall timed that. Oh, there it goes. My computer's just running slow. Sorry. So if you go to Bottle King, and if you were to go to the firewall objects, again, the virtual IP section, if you notice when you go to create one, click on port forwarding, you see it has an option for an external service port and a map to port. It has the same thing here. So this, if you don't select port forwarding, what happens is it does a one-to-one NAT from this public IP to this inside IP. So basically, nothing else can use that, that public IP. So, I always do port forwarding here. I always enable this. Unless a customer says, hey, I want this public IP, specifically to map to this private IP, and I don't want a specific port. I want all ports mapped to it. In a sense, that can be dangerous because now, even though it's hidden by the private IPs, the public IP is hiding the private IP, you're still forwarding all ports from that public to the private. So if anyone gets a hold of that public IP, they can technically hack that server or whatever's behind it.
Sure.
So this is where you create your virtual IP. When you go back to the policy section, though, this is where you allow the traffic into that virtual IP that you've done your port forward. So if you click on one of these as an example, I selected the actual virtual IPs are, down on the bottom here if you scroll down. Now, that's the destination address. Now, you can even make this even more secure. When you create the virtual IP with the port forward, you're already doing the port forward. The policy is just dictating what services are allowed into that virtual IP. So you can technically leave this to all, and because the virtual IP already allows port 80, it's already going to only allow port 80. Nothing else is going to be able to hit that virtual IP except port 80. You can even get more secure if you want by adding by only allowing HTTP. So it's kind of like a double. Do you understand what I'm saying?
Yeah, you essentially get to dictate what services are allowed to be able to run on that virtual IP. Yeah.
Correct.
Now,
because
I'm sorry, by the fact that it's a virtual IP, that means we don't have to pull an IP from like Orion. We can use whatever IP space we want, and it won't affect anything, right?
No, you still have to pull public IPs from Orion.
Not the public. I'm talking about the privates. On the private side.
Oh, right. The private is dictated by the customer. Whatever the inside IP the customer wants.
Yeah, okay. That's what I want to make sure.
The public IP that he wants mapped to, you need to pull from Orion as a block.
Right.
So basically, like I said, the virtual IP already inherently, if you enable port forwarding on the virtual IP, you're already inherently limiting what traffic can access that private IP. So in the policy section, you technically don't have to put the actual type of traffic because your virtual IP is already limiting that. But you can still limit it if you want to. For easier sake, if you go to the policy section, it's just easier if you go to the policy section and see, I only see HTTPS traffic, that can access the server. It's easier to see than just seeing an all policy. Because then you have to go to the virtual IP to see what actually port is forwarded.
So I have a question.
Go ahead.
Is there a way to do a range of ports?
Is there a way to do a range of ports? So that's a good question. So if you select this, so you can actually do it here. External service port, you would put your low, and then you would put your high.
Okay.
And then you would put your low, and then so your external service port is what the firewall sees, on the outside. The map to port is what the actual inside server sees, responds to. So, in some cases, maybe a customer says, hey, I want external port 80, but on the actual inside,
sure,
the server responds to port 80 on port 500 or 5,000 or something.
Right.
But you can put your range here.
But so if you wanted to do, 80 through, or, 5,000 through 10,000, you could put your range there, right?
Yes, you can, yeah.
And then put whatever he wants on the inside, if he wants it to be the same, or if he wants it to be
whatever he wants, right.
Yeah, right.
And you can actually test that connectivity a lot of the times, like if you want to know if that inside IP responds to that port, like go to the local router where the server sits behind. When you're on that router, tell net to say that server on port 80. Do you get an open response?
Sure.
If yes,
yeah,
then the inside server is responding to it. Then you can go back to the firewall and see if you've got it configured properly. If you have it configured properly for port 80, you should be able to tell that to the public IP on port 80, and you should get the same open response.
You'll get a response, right? Yeah,
right. So this is how I've always done port forwards for virtual IPs for public to private on the FortiGate. You can tell here, like I said, I'm actually, as well as the virtual IPs are actually port forwards. You can tell here by parentheses. This is dictating the actual port forward, but I'm also limiting it in the policy, so I'm kind of doing double duty. You don't have to, but I always like doing it so it's when you go to the policy section, what's actually being allowed.
Go ahead. If we gave you an example, could we do one from start to finish? We could do one of the ones just bottle.
Yeah,
well, right now on Bottle King, what I don't see, George, is I don't see, and I may have missed it, but I don't see one public per site.
So how many sites does Bottle King have?
It has its own public, yeah.
Each one has its own public?
Yes, because they're all inside their own. They're all inside the VRF as an MPLS. So each site has its own WAN interface public. Its own WAN public.
Oh, okay, but hold on. Does the customer specifically need a public IP per site, or can he deal with a couple of public IPs with different ports forwarding to those actual inside servers?
From what he's explained to me is that he wants a public per site. Isn't that correct, George?
That's how I understand it. They want to be able to. I thought they were going to just use the publics that are essentially the WAN interfaces of the routers. So I don't know if that's correct thinking, or if I need to pull a separate block of public for this security camera request. The customer wants access to cameras from an app.
I mean, I would think he would want one IP. Let's check on that, Curtis, before we. It would be easier if he's accessing the cameras. He's just going to change the port on them. Is really what he's doing. So he could use the same IP and change the port on each one. I don't think he's going to want to have 20 different or 50 different IPs. You know, it might be 20 different IPs and 10 cameras per site. So that that's a lot of variables. If it's the same IP and you just change the port on each one, that's the way I would do it.
Yeah. Now, is if the customer has, say he needs to have, like, say at site A, he has like 10 cameras and he has a range of, where camera 1 has this port, camera 2 has this port, camera 3 has this port, and so on and so forth. But then at site B, he uses the same ports as site A. Then you would need a separate public IP for that.
Absolutely, sure. And that's what I told him. But from talking to him and going through his sheet, none of the ports are the same. Because when he first sent the thing across, it wasn't clear until I talked to him. So in that sheet that he sent, there's a lot of outs. So I was telling him, hey, you can't have a port and you can't have any. But for what he was telling me, any is just out. And I said, all right, fine, then we're not blocking anything on the out. So, and that's correct, right? We don't block anything on the out, do we?
Anything on the out? No, because that's covered by your global NAT rule.
Yeah, right.
Right here.
Sure.
This means everything's from that inside to outside. Now you can restrict this to be even more. Again, it's a firewall. You can be as restrictive as you want.
You can do it if you want. Right. Yeah, absolutely.
Yeah.
I just mean on the general policy on the out is open, right?
Yeah. Sure. So I mean, you can get even more restrictive. You can define all their LAN interface, all their LAN IPs here, or their LAN blocks, and then you can go to the policy section. Instead of having all, you can list all their inside IPs instead of doing it all.
Right.
So this brings up another thing about customer port forwards and public IPs and whatnot. So if a customer has a need for more than like a couple IPs or more than one IP, the way that I like to do it is right from the get-go. Hold on one second, I'm trying to pull up my go. Is what I like to do is I like to get that information up front. Hey, say I need I have a specific need for, say, 13 usable IPs on this managed firewall. So what I'll do is, instead of doing a /31 on the WAN side, I'll do a /28. So then there's 14 or 13 available more IPs that they can use within that block. Because the way you did it, you did a /31, right?
Yeah, I did the standard /31 on each. Yeah.
So so now that /31 only provides one usable IP for port forwards on that, from the outside. So if the customer does have a need for any additional IPs for port forwards, you have to pull a separate LAN block, a separate public IP block in accordance to how many IPs they actually need, and you have to route that public block over the WAN.
Well, I think I put a DIA on it for /28, but let me look.
Yeah, I'm just saying, the way I like to do it, the way I prefer you guys do it is get that information up front. Say I need 30 IPs. Okay, well, I'll pull a /27 for the WAN instead of pulling a /31.
Right.
So you have to route it through the WAN of the router or the inside interface like you did the other ones.
No, so all you have to do is basically, the way George did it, he's got a /31 on the WAN on the external side, so that only provides one IP for port forwards. For anybody.
Sure.
If any,
right.
So what he does is, if customer say needs, well, I need 10 more public IPs, he has to take, he has to get a block of a /28. He has to route that /28 over the /31, and then it becomes available to use on the firewall. He gets all 16 IPs.
And the /31 is already routed. That's where you route that through the inside, so that's how it knows how to get to it. All right, I got you.
Right.
Yeah. No.
That's.
I was just trying. Yeah, I got all of that. I just was trying to differentiate between what gets routed to the inside, part of the VRF as opposed. But since you've already put the LAN blocks into the inside of the VRF in a route, you're saying just route any LAN block or any bigger public block to the actual WAN IP. I got it.
Right. So the actual public IPs the actual public IPs that you have on the routers right now, those are just for purely monitoring purposes. They don't provide any port forwards. They don't do anything for the customer. That's just for our connectivity and for our monitoring. Right. Okay.
Yeah, I understand. I just meant just in terms of routing in the firewall and the differentiator between what you're routing between the inside VRF and the actual and how it gets there. But I think I understand it now.
Yeah. So in the past it's been done. A couple. It's been done either way. One way it's been done. People have grabbed a larger block for the WAN interface, and then they have. On the other way is they've done like a /31 or /30. Then they've routed a larger block over that. I prefer you guys charge a larger block to the WAN so we can be more conservative with the IPs.
Sure.
Okay. And it's kind of like the same thing, like if we were doing, like if you had a customer that didn't have the managed firewall, you would provide them like a /29 or /27 on the LAN side of our router, and then they would get those IPs. So it's the same kind of concept. It's just, instead of being on-site router doing that, it's, in our cloud, it's in between the router and actual outside of the firewall. That's handling that larger block.
Sure.
Do you guys understand does everyone understand what we're talking about? I want to make sure. Speak up if you truly don't.
Speak now or forever hold your peace.
This is being recorded, so you can of course go back and re-listen to the training.
I'll definitely have to re-listen to it. I came in like 40 minutes late.
No problem. Yeah, the first 5 minutes or so went over just the basics of how it connects to the burr router. So let me review one more thing before we go over an example. So the last piece that that customers may ask for is say, hey, I want access into my my private network from like a VPN client. Like how Fusion's employees connect into our network. How you connect with the VPN client at home. So this actually has an example. Like if you go to X1, you can go see. I don't like this here because you can just clutter it so badly. Let me minimize some of this stuff. Pain in the butt seeing all this. I hope they do something about that. So if you go to the VPN section, go to the tunnel, you'll see this is the dial-up tunnel. And this is, if you click on it, you'll see how it's configured. So it tells you 100 concurrent users will be supported on this firewall. Excuse me. You can go to each section and you can see how to configure it. I configure this in a way, basically, so when you give them the client, I can forward you the document that I sent to X1. It's basically like the Fusion one. It's just, I retyped it up for X1. Where they install the client from downloading it from Fortinet, they don't have to modify any encryption settings. They just put in the pre-shared key, and then it asks them their username and password, and they connect. That's the way I configure these dial-up VPNs. And this ends up being split tunnel, by the way. There's a few ways we can do it, but this is done as split tunnel, so all the internet traffic goes out, the normal broadband, and any of the interesting traffic comes in, from the actual tunnel from the VPN. Sure. You can look at all these different settings, going through. log in and just take a look at them. And then the interesting thing to note is your policy here dictates what actually gets sent over the VPN tunnel. So if you look, this is an address group. Consists of a bunch of different addresses. You click on it. Show it'll tell me. So if you click on it, it'll tell you that. But if you go to the address and you go down to the address group, you'll see what this address group consists of. So because this is an address group, that makes it a little bit cleaner. When they actually connect to the Fortinet client, like what we use, they will be sent all these addresses across the VPN tunnel. So if they do a route print on their local machine, they'll see all these private addresses going across the tunnel. And this is the subnet that I've dictated for their remote VPN clients. When they connect, go to the tunnel section, you go to here. This is like essentially handing out DHCP across the VPN tunnel. So, they each get an IP address, their local client. So, and this tells you what the accessible networks are. There are other options, like a customer can do SSL VPN if they want, a little bit more secure, a little bit less. It doesn't have as much throughput as a regular IPsec. And you can also do an L2TP tunnel, which is not split tunnel. That will end up tunneling all the customer's internet traffic over the VPN. I don't like doing that because you got to be careful because tunnel customers' internet traffic all across the VPN. With high broadband connections these days, you depending on how much traffic they push, they could saturate the actual firewall CPU or the actual bandwidth on the across the interface. So just something to take note. I always use dial-up VPN. Unless the customer specifically says, I need all my internet traffic to be tunneled over the VPN, I would always just configure them for this. Okay?
Okay.
So a couple other things, you can define an IP pool. So like if they want another in-to-out NAT rule, you can put it for a different IP, you can put it here. It's kind of like a NAT overload with a NAT pool on a Cisco is what that's equivalent. You can define custom services. So like if you don't have they have some oddball service that's not already defined here, you can create a new one. So you can name it whatever you want. You can put the different stuff here. You can put the TCP, UDP, or both if you want. You can specify source ports if you want. Source port is usually going to be that random port, random ephemeral port that that an arbitrary connection comes from the outside. So you don't really have to specify the source ports unless it's needed, but usually not. You're only concerned about the destination port that it's going to. You can do some DOS prevention. Sure. You can do some basic email filtering and intrusion prevention as well as web filtering. But if you want the category stuff, like the more specific stuff here, it'll tell you. Let me see here. So basically, if they want to do like more advanced web filtering, like that's up here, it gave that warning that you need the actual license for it. With this disabled, you can do some basic web filtering. You can filter based on, you can define URLs and stuff like that. But that's when, if you go to the global here, it'll tell you here the license information. So right now we don't have web filtering. We don't have web filtering on this. So if a customer has a specific need for the premium firewall or like for the advanced web filtering features that give you content-based filtering, that's when you have to come to NE and say, hey, this firewall is not licensed for web filtering, so and so a customer needs it. Can it be licensed? But we don't do that. We don't do that out of the box because not all customers need that advanced web filtering content. Any questions on that?
No.
Nope. Okay. So these host names will be renamed in the long term. I'm thinking of a unified naming convention, so it we don't all get confused. But they all are already on Orion, all the firewalls. So let's go over something for Bottle King as an example. This firewall probably timed me out already. I forget what the timeout is. Nope, it's still there. It's like 5 or 10 minutes, and the firewall will log you off, and you gotta log back in. So let's go to Bottle King. Well, as you see this is right now this is a /31. So if the customer does have any truly need for any more than one IP for port forward, you'll have to route a larger block over that.
Right.
So let's see. You had it. Hold on one second. Can I open my? Hold on one second, guys. See if I can open my email. They're reviewing my VDI.
So on that, they may. I mean, what they had before is they had multiple IPs. They had more than one, at least. They had a few. So we're gonna have to check on that.
Okay, hold on. Sorry. I'll be about probably another 15 minutes or so. Yeah, I know. I'll go to my email so I can get that spreadsheet. I'm sorry, Brian. Can you go ahead and ask that question?
What I was saying was that on the spreadsheet he sent, he had multiple publics. He didn't have one for every site, but he had more than one. So I have to check on that.
Yeah. I'll look just. So when you create the actual internal and external interfaces, sub-interfaces, use different VLANs, even though they're coming back to different ports. Going forward, use different VLAN numbers. Please don't keep the same one.
Sure. Is that for you when you did the change? You don't have to change them going forward?
Yeah, well, with the 500A, it's unfortunately a lot of them on the 500A are the same now for internal and external, so I have to do a Q and Q.
Right.
So I can, maintain the same VLAN for the inside and outside, or I don't know how I'm going to get around that, because a thing to note is once you create the actual interface, you cannot modify the VLAN, which kind of really does suck if you think about it. So if you wanted to change that VLAN and you have to basically delete all the policies for that interface, turn it into that interface, delete the interface, and you have to recreate the interface. It's unfortunate, but that's just the way the 48 works. So another thing about the 48 is if you need to remove something, if a interface is dependent on policies, you have to remove the policies first. If the policy is dependent on users, you have to remove the users first. So it's it's a safeguard on the firewall mechanism. So it prevents you from removing an interface if there's other dependencies.
Right.
So let's look for that email. Who did that come from? Alessandra?
Came from me.
Yeah.
I sent it on 3/14 at 6:24.
Okay.
Are you looking for the actual sheet from Bottle King?
Yeah, I see it here. Okay, net roll. You guys can still see my screen, right?
Yes.
Okay. Okay, what is this FR config here? I'm kind of curious.
So there's a lot of garbage in there. Oh, go ahead. Let me check that out. So there's a lot of garbage in that sheet that he sent, but pretty much I think the only thing he really cares about is the public to private on the port.
Yeah, I'm just looking here. What's in that translation? Net translations are not on here, I can tell you that. It's just an access list.
Yeah, let's wait, make sure. I'm sending Alessandra an email right now.
I see what he's doing. He has an any here, so he's not specifying any ports for a lot of this stuff.
Well, that's what I said, and that was my concern, and that's what I talked to George. But the any, he said that's just on the out. If you look on the left Where it is on the left to the right, that's out to in, and it's any. It's really the only thing is where the ports are.
Mm-hmm.
If you go down a little bit further, on where it says, you're sending any from 173 from the public, like on line 59, from the public to the private on that port.
Right. I see.
Right.
Okay.
That's what he's concerned about. The rest on the left that say any on the left, or that say the IP to the public and say any. He says those are out. That's what he explained to me.
Okay. Yeah, this cannot exist. How you have like the same.
No, I told him
mapping.
That's exactly what I told him. And George will tell you that was my problem because he sent it. I was like, this makes no sense. You can't have. That's what I was saying because it looked like he was trying to do multiple IPs to a one-to-one, and it just can't be. I get it. So.
And that's what I told him, and that's how I got escalated to Brian.
From what he's saying, that's all on the out. If you look on the left, the stuff in the yellow is all on the out. The stuff on the any on the left to the public, to the private is that's what he's concerned with the 173.210 to the private on whatever port is from what he explained to me.
So this Ike here, I don't know if he's got an existing VPN or something, but we can just go over that briefly. A site-to-site VPN setup. I'll go over that with the X1 example. But for now, let's do one of these. So let's do this here. So sort of 500 a. My screen is small, unfortunately. Sorry, guys. I'm working on a 17-inch screen. So what we do is we want to go to the VPN, to the firewall objects. Let's take line 59. Okay. So he wants TCP 888. Okay, or quadruple 8. You will go to the virtual IP section. So I don't know what this inside IP is, to be honest with you. So I'm just going to name it 10.10.1.20 888 TCP 888. Okay, just because I don't know what that server name is, unfortunately. So what is the outside of this firewall?
I think he only has one address at 170.
Yeah. So let's get that. I forget where it is. Here it is.
216.
Again, I wish I would go back to this construct because it's just horrendous. You get cluttered so easily. So, do this again. So we're going to name it 10.10.1.20. So with TCP 888. 8. So the external side is going to be 216.86.46.113. And then the mapped IP is going to be 10.10.1.20. Now I'm going to do a port forward. TCP 888, 888, 888. Okay. Now that's our virtual IP. Now we go to our policy section. Now again, if you want to make it simplistic, you can just do this. You're going to go anything comes from the external side going to everything. Coming from everything, going to the internal side, destination is going to be this here. This is the virtual IP we created. And then, we can do any. Because the port forward is already dictating what ports to forward. We don't want any NAT because the virtual IP is already doing that NAT for us. And we do OK. And there's your actual port forward rule. Now, again, I can get even more granular if I wanted to. I can go to the address. I can go this way. Oh, no, sorry. Service section. I can define a custom service and just say TCP 888.
Right.
888. This is always the same. The source is always that on the older. And then I can go back to the policy section, and then I can change that now any to TCP 888 if I want to get, even more, even more secure, if you will. But, it's kind of redundant because, again, the port forwarder is already doing that for you. This would only hold true as if you were doing the one-to-one NAT, where you're forwarding all ports, then you would want to limit in the service here. So now, this IP, the outside IP, 216.86.46.113 on port 8888 is now forwarded to 10.10.1.20. Let's see.
Well, I don't know if that site. Well, that site may not even be up yet.
Oh, okay. But what you can do is this. You can also troubleshoot this. You can SSH into the firewall for one. I always suggest SSHing into it because under the little GUI there on the front, it's kind of hard to do this stuff.
And we'll ping that private.
I just got locked out again. Damn. It's going to take me a few minutes. I mistyped the password. So that's how you do a port forward. You can do some debug statements. I'm just waiting to get on the. Maybe it's probably going to lock me out from there. But I'll wait on that. But I'm just waiting for it for me to unlock, and then we can go through. Do you have any questions on how I did that port forward? So under the virtual IP, I defined. You can even define the external interface if you want to. Specifically, I always put any, but you can always, specify the exact one.
Right. If there's multiple.
Yeah, I understand that, but I need to really do it for myself. That's how I catch on to it really good. Is there any documentation you got, Curtis?
Well, there's a lot of Fortinet documentation online on all this stuff. They're pretty good at documenting that, but I don't have anything that I have created.
So, Jason, still there?
I don't know if he dropped off or still there because he's in.
He may have. So, Brian, normally what Reed did for everybody is get them one of these boxes so they can play with it. I'll see if Jason can do that too. Then you can put it on your network or whatever. You can get a public, you can put it on your network, and you can go on and do all kinds of stuff with it.
Okay. All right, sounds good.
Okay. So now I've SSH'd into the CLI of the actual FortiGate. You can do a lot more stuff in the CLI than you can do in the GUI, but it's easier to configure to the GUI. Just putting that out there.
There's a CLI from the GUI. There's a CLI command prompt too, right?
Yes, but it's a lot easier to do it through an SSH session because if you do copy and paste, it becomes a pain in the butt doing it through the GUI, that little widget. So with a VDOM.FortiGate, you do config. You can always question mark it, just like at Cisco. It tells you what you have available. You can config VDOM and do edit. So you want to do, we can do Bottle King, right? And you can tab it out too, okay? Now we're in the Bottle King VDOM, and you have different options. You can look at get, like when you do a get, it's like kind of showing the actual configuration parameters. Show is like kind of you're doing diagnostic, you're showing showing stats of something pretty much, and then you have your config. And you have execute, which is basically like you're kind of like executing functions of a router. Like you can execute router, clear OSPF. You can clear the OSPF process if you want to, type thing. So let's do a debug here. So there's two types of debugs you can do. You can do a diag. You can do a diag sniffer packet, say any interface, and you would do single quotation coming from a source that's 216.86.63.186, and do that. Now you can see when I tell that to her, you can see what's coming in and what's happening. This tells you like kind of like a higher level view of what's happening with the traffic. You can see it coming in. It's coming in the external side and it's going out to the internal side. So that's kind of briefly now, kind of like a higher level debug. You can do a lower level debug, which again, you have to be careful of both commands, because if you just say do diag sniffer packet and enter, you'll get everything going through that VDOM. Where, you know, if there's a lot of traffic, you can kind of hammer that. You can kind of saturate that firewall. So you just got to be careful. That you can do diag debug enable. There's another one. Diag debug filter. Oops, wrong one. Diag debug flow. First, you want to enable console on enable messages on the console. Debug flow trace. Let's do a filter. Let's do by I usually go by ADR and do say 216.86.63.63.186. This is the outside IP I'm coming from. Do diag debug flow filter. You can do different options, but that's all we want for now. Now we do trace start 20. Basically, you're going to start it, and it's going to go for 20 lines. You can do 100 lines. You can do 500 lines. Just be careful. And always specify an address or some type of filter. If you don't specify a filter and you start this, you're going to get everything going through that VDOM. Again, it can be service impacting depending on how much traffic you're going to just get flooded with information. So I started it, and now let's try that. Tell that again. Now this is a lower level debug, and it's telling you what it's actually doing with the packet and where it's coming in. Let's make this up a little bit. So you can tell it's coming in from Bottle King. It received the packet from the outside. It allocated a session. It's finding a source NAT, which is from our NAT, and then it's destination NATing. So it's going from that that public IP to that inside IP, and it finds a route, and then it's allowed by policy too. That port forward that we define. This is a good way if you're having trouble getting a policy to work, like a NAT policy or something. If you see it denied by certain policy, then there's something wrong with your there's something wrong with your policy statement. But this is a good tool for troubleshooting. But again, you got to be careful of how you use it. You don't want to just arbitrarily enable it with no filter on it. If you do enable it with no filter, what you can do is you can break it. You can hit like Control C, and it'll exit out of the FortiGate altogether. So just be careful. So this is a great tool. Like on a Cisco ASA, you can go to the log section. This is kind of the equivalent of that but doing it in real time, so you can troubleshoot. So it even tells you, what the ephemeral port I'm coming from. That random source port that I'm coming from. Any questions on that?
No.
Okay. So let's look at one more thing. Let's go to this one here. This one actually didn't time me out. Let me go to the X1 one. Go look at a site-to-site VPN. Go to the virtual domains. Go to the X1. Go to the VPN section. Again, hey, how it does this. Here it is. Tunnels. So this, my friend, there's two types of modes you can put a VPN, and you can do a tunnel mode or an interface mode. Tunnel mode is like your normal, like the equivalent of doing crypto maps on a Cisco. I know some of you are familiar with that. An interface mode is like a VTI on a Cisco, virtual tunnel interface, where you're actually encrypting the GRE tunnel in an IPsec payload. That's kind of what an interface mode does. It allows you to run routing protocols over it a little bit easier, and you can specify source and destination IP on the tunnel itself. Tunnel mode is just good for doing standard IPsec stuff. So this is the VPN to this customer's Germany location. And here's all the settings to it. You can lock. So a thing to note about phase 2. As soon as you specify a phase 2 in the local, I sent an email about this. If you specify a local and remote address under phase 2, you lock that VPN to those two source and destination addresses. The only time you really need a local and remote in a phase 2 section is if you're interacting with a non-FortiGate appliance. If you're going FortiGate, you do not need a local and remote address. You can leave that blank for all zeros. What that means is then your policy dictates what gets encrypted over the tunnel. But remember, as soon as you specify a local and remote, you're locking that tunnel to only those IPs. And any other, if like you need any other IPs to talk to each other over the VPN, you have to create separate phase 2s for additional nets that need to talk across the tunnel. Like if you go to the IP section, the policy section here, this is the actual, IPsec policy that is encrypting traffic. Here. You can go to the monitor section. Monitor, IPsec monitor, you can tell that this tunnel is up. And you can tell how much incoming data and how much outgoing data. You can actually manually bring it up and bring it down too if you right click on it. So if you're having trouble getting a tunnel up, you can right click to try and bring it up, and if it doesn't come up, you can go to the log and report section, like go to the actual event log, go to the VPN here, and then you can take a look and see what's happening. If there's an error or something. Like for the Germany one, since it's up, it's just giving you progress stats basically. So that's how you would create a site-to-site VPN. So again, when you do VPN site-to-site VPN, both sides have to match. The encryption, the authentication, Diffie home group, all that kind of good stuff. The key life, whatnot. And if you create a VPN in an interface mode, it creates another interface for you, so you can route stuff. So you can create different policies. So this is for the remote VPN, for the remote VPN clients. But if you notice, if you go to the actual interface section, go to the external, see, it'll actually create another interface under the interface section. You can technically assign this an IP, but because it's just for remote users, you don't need it. If it was a site-to-site VPN where you need to do different routing protocols over the actual interface, you could specify an IP and then a remote IP. On a FortiGate, it's a /32. Two individual /32s. On a Cisco, when you do a VTI, you got to do a /30, at least a /31. So it's a little bit different on the FortiGate here. That's if you had a site-to-site VPN and an interface. Any questions on that?
No.
Okay, so that's pretty much all the stuff that you would need to know about the Fortinet. There's a lot of information that was covered in this call. It'll be available in the recording, so you can go over it again. So, and again, anytime a customer needs more advanced web filtering, IPS, or anything that requires a FortiGate license, that's when you have to come to network engineering. Hey, say this Fortinet's not licensed for this stuff, but the customer is paying for it and the customer is requiring it. Can we obtain the license for these features? But they are not inherently enabled by default, because that's a monthly subscription to the Fortinet services. Okay.
Okay. Hey, Curtis. I emailed Alessandra. Looks like they just want a couple, just in case they ever get an overlapping port. So George will work on that.
Okay. So this day
George, just get another public. That's all you got to do. They got two is fine.
Yeah. So is the customer actively going through this firewall right now, and is it in use?
No, I don't think so. Right, George?
George still there?
Yeah, I don't believe it. Let me. Let's see.
I still see him there. So basically, if the customer is not using the firewall right now, like there's no traffic going through it, replace the WAN interface with, say, like a /29 or /28.
Right.
If the customer is actively going through it, then just route a /29 or a /29 or a /28 over that WAN.
Sure. Got it.
So, does anyone else have any questions of what I went over? No? Okay. So just to recap, there are 4 individual firewalls right now. They will be condensed down to a couple 200 deep.
Morris Plains is
So Morris Plains is actively using the firewall.
yes.
Okay, so then grab how many additional IPs the customer needs.
pull in an appropriate block. So like say if they need if they only need 2 IPs, pull a /29. If they need if they need say 10 IPs or they need 9 IPs or something, pull a /29.
No, they only need two total, really. So I mean, I don't even know if they need. Wouldn't do even a /30, but
you'll only get 2 IPs with a /30.
Yeah, so
that's all they want is
if you pull a /30, if you pull a /30, they'll technically get 4 IPs because you're routing over the WAN and all 4 are available at that point.
Okay.
But if they play on the safe side, give them a /29. Because if they need 2 more down the road, then they're at capacity, and then anything else you're gonna have to pull another block because you're not gonna be able to probably expand down the road. So always plan for future expansion. If they need 2 or 3, give them a /29.
Right. That's been the rule for phones and everything.
So just
give them the room to grow.
So George, just kind of follow the sheet. You'll see he has a couple different publics that he's mapping to. So just kind of follow the sheet. Every port that he has did a one public, and and every port that he has on another dude, with the other public dude.
I'm pulling a separate public, putting it on an interface, routing it over their WAN, putting it in the firewall for the mapping portions.
Yeah.
Okay.
Pulling a /29, routing that entire /29 over the WAN interface. The next hop is the firewall current WAN interface, and then all those 8 public IPs are available now on the firewall for use for port forward.
Not a problem.
Yeah.
Are we done with the training section, or are you still going on?
Yes. Nope, that's it. Going forward, the way we like to do it is, get that information up front so you can give them a larger block on the WAN instead of a /31, so you don't have to route over the WAN.
Now, per our normal, when I'm ever doing new stuff, it's okay if I get it built and then just shoot you an email to kind of look it over, just to make sure.
Yeah.
Mm-hmm. All right. Okay. I've got to go jump on another call, guys. So I will talk to you guys in a bit. Unless we're still doing training, then I can tell them I'm not available.
Okay.
I think we're all good.
Hey, Curtis, I have a quick question, not to hijack this call, but I wanted to ask you, and maybe better take it offline, what it is that, let me just ask real quick. So we have another customer that got escalated to Russell yesterday, and it's just a megapath layer 2 off of the, I think it's off the LaGuardia Burr, and they just have VLAN 1109.